Hello, my name is Robert Smith, and I'm with New River Community College's academic assistants, and today we will be discussing average atomic masses. In the example given, we see that two stable isotopes of carbon are carbon-12 and carbon-13. The notation that you see is the proper notation for an isotope, wherein the total number of nucleons sits over the total number of protons and to the left of the element's symbol. So the mass of carbon-12 is 12.00 AMU and has a natural abundance of 98.90%. The mass of carbon-13 is 13.003 AMU and has a natural abundance of 1.10%. What is the average atomic mass of carbon? So that is what we need to find out from the information provided. So the first thing I generally want to do whenever I look at percentages is to try to convert them to decimals, because decimals are easier to work with than percentages, at least in chemistry. So 98.90% is the same as saying 0.989 and 1.10% is the same as saying 0.011. It's fairly simple. So once we've determined that this is the appropriate decimal equivalency to the percentages given, we can look at getting our average mass. And the formula for average mass in this case, when concerning isotopes, we're going to say mass average is equal to the mass of each specific isotope multiplied by their respective abundance, which is why we wanted to convert the percentages to decimal. So in this case, it would be 12.00 AMU times 0.989, and that would be the mass of carbon-12 multiplied by its abundance. But to that, we need to sum that with the mass of carbon-13 multiplied by its respective abundance. So that would be 13.003 AMUs times 0.011. Now, if you multiply each species by its respective abundance, you'll see this equation will simplify down to 11.87 AMUs plus 0.14 AMUs. Then you just combine like terms, you add them together. Once you've summed them up, it becomes clear that the amount, the average mass, is 12.01 AMU. And that's significant because if you look in your periodic table, you will find that the mass given for carbon is 12.01, which means that every single mass that you see on the periodic table is a representation of the naturally occurring isotopes, the masses of those isotopes, and their respective abundances. Once that has been calculated out, they're summed, and that is the mass that is presented in the periodic table.